Thank you.
So I call you a techonomist. What I really would like to ask first is, what's the common thread between everything that you do?
Well, I think there's two. One is that I like to learn new things. And so getting in fields that are deep, and there's great scientists, and there's something that I can read about or watch lectures about, I always love that. But more importantly, things where innovation can be tapped to change the state of the world. Whether it's dreaming about what a personal computer or a great software market could turn into, or dreaming about a vaccine for malaria that would save all those kids' lives and really transform productivity in significant parts of Africa. It's kind of an innovation. And so I love looking back at history and seeing what a great role innovation has played, whether it's David Christian or Václav Smil. It's amazing to think that the framework that we exist in has been so changed by innovation, what's possible. Many dead ends, tons of lack of realism about which things will happen, and yet some magic combination of the marketplace and research has made the last 200 years pretty special. And it's fun to think, okay, can you pick some of those things, make them move faster, and make them benefit the people in the most need in a way that the systems naturally do actually a very poor job of that.
Well, give me some examples of where the marketplace kind of, I don't want to say it fails, but it doesn't do as good a job as it could to encourage innovation.
Well, I'll give 3 examples. One is take an energy technology like nuclear. You're not going to have a lot of people putting down money when the siting delays, the waste problems, the time period to get something done is actually longer than the length of a patent. It's longer than people are patient about risk-oriented capital. It is so unclear, particularly if you had some new design that the regulator would have to get used to, would you be alive when it finally got approved? A lot of people like to work on things that happen during their lifetime. And it's particularly if you're not that religious, which is one of my problems. So the lack of investment in there is very understandable. If you look at diseases, if a disease is in the rich world, then you get this trickle-down effect. You solve it for rich consumers, they fund the R&D, then you get differential pricing, and there's cheap medicines either at the same time or over time for all the people in the world. Now that fails if the disease doesn't exist in the rich world, and malaria is a great example because it's been eliminated. It was in the United States in a big way, it was in Europe in a big way, but we got rid of it. Temperate zones, it's actually, with a little DDT, easy to get rid of, not easy, possible to get rid of malaria. In tropical zones, those tools alone don't work. And so no work has gone into it. When we did our first $50 million grant for malaria, we became by far the biggest funder of malaria research. And for something that kills 1 million kids a year, it seems like, spending 10% of what you spend on erectile dysfunction, maybe it'd be a good deal for the world overall. But the market wasn't sending that signal. You also get things where the rich world has very expensive ways of doing things, like ARV treatment, the way AIDS treatment is done, that doesn't map to what can be done practically. And then the final market failure, which in some ways I think is the biggest one of all, is you have big sectors of the economy like education and healthcare. But let me just use education, where if somebody's a great teacher and they have a technique, either technology enabled or just in person, the ability for them to be identified, that best practice to be figure out how to transfer it to other people and create an incentive for that to happen, it doesn't exist. If you had to create, say, okay, the chip industry spends 18% on R&D, the biologicals industry spends 14%. If you took all the spending on education, which is primarily through taxes, and said, okay, what's the R&D percentage in that industry? In chips, you really would never say that somebody who made chips in 1860 was better than somebody in 2010. You just would never say that. In education, if I told you, oh yeah, the best math teacher, that was a guy who taught math really well in 1860, you couldn't contradict me. I mean, it's potentially true. Of course, we have no metrics, which is a great proof of how undeveloped the field is. But can you say that there's been collective learning that has led to a much higher performance standard over that time period? Not at all. So the effective R&D that goes in is pretty near to zero, and that's a market failure.
Well, let me ask you another example. You mentioned right up first that nuclear projects, not only do they take too long, they're too expensive. You mentioned malaria, which is an enormous problem just to understand the climatological factors. You have put together, I guess it's a supercomputer. I'm not sure what it is. You bought for intellectual ventures, and they've been tackling both these problems there with the notion of simulations, being able to at least make it a little more practical to try to get to the point of being worthwhile to build a working prototype. I know that's the case with the nuclear one, and with malaria, I'm sure there are other ways you can quantify the benefit you get from that. But I'm just curious about the notion of using modeling to accelerate the development process at a lower cost so that it isn't one of these things that's just so onerous that only governments can do it.
Well, that's a very important point. If you think of why science advances, you often point to somebody discovered this drug or somebody discovered that drug. In fact, the reason biology advances is in tools. Tools like PCR or RNA interference. The tools guys sometimes get visibility, and sometimes they don't. But the real metric of the science comes through the tools. The fact that chip design went down to smaller and smaller design rules, that enabled software ambition and a software industry. The general idea of simulation, whether it's fluid dynamics, alloy behavior, nuclear reactions, cars crashing, the general impact of modeling on the pace of innovation in the world at large is deeply underestimated. It's one of these fantastic things. Now, it's another thing that it's easy to get under investment on. When we first started working on diseases, I said, well, of course, the government must have this great model about flu or bioterrorism, and we can just plug some parameters in. Because, after all, if you watch the TV series 24, those guys have a little model that says, should we evacuate LA or not, and what if the bomb goes off and all that. So I thought, if Fox has it, maybe the US government got a copy from them or something. Well, in fact, there's no disease modeling software, period. There is none. The most basic questions have never been explored. Why is flu seasonal? No one knows the answer. Can you actually do a good model without figuring that out? No, deeply underinvested. And so we got, Nathan Myhrvold has a group of a lot of Lawrence Livermore veterans, some Microsoft veterans, various people are doing broad science things. And we're doing two big modeling things. One for the nuclear project, that funny, crazy group called TerraPower that has a new nuclear reactor design that on paper it's quite amazing. But it's hard to go from here to there. And for all this disease stuff, because we want to know, can we eliminate malaria? Do we have the right tools? And you never want to start to try to eliminate malaria without enough tools, because if you start using drugs and nets, the bug and the parasite, mosquito and the parasite, start evolving away from your tools. And so if you put pressure on and you don't get to zero locally, what you do is you get a better mosquito and a better malaria, Plasmodium. And great. Now you've made your job for even harder because you wiped out those tools. What you need to do is intervene, but only a model could really tell you that, and it's kind of complicated. So the whole modeling thing, I think, is incredible. We're going to put out for free this disease modeling package and let all the researchers go in and take their understanding of weather or mosquito species or drug interactions and apply that so that whether it's flu or AIDS, there is actually collective learning that's not taking place today.
How do you know your models are right?
Well, the models are never right. It's like all these models. We take history. So we take malaria elimination in the United States, and we put in all the parameters. What did they do? What were the species? How did they behave? How many females got killed? How did the female lifetime get affected? And we see, do we come out with malaria elimination in the US like it did in the real world? We look at Italy. There was a project in Nigeria, this is getting obscure, called the Garki Project, where they did an intense thing of trying to eliminate malaria locally for 3 years. They used all the tools of the day, including lots of DDT, very well done, and they failed. But they gathered massive data about one species went down, the outside biters didn't go down. Anyway, so we put that into our model, and we see, would it have predicted exactly what happened in Garki? Would it have predicted what happened in Madagascar, Papua New Guinea? Our model shows malaria going up and down in the winter, in the different seasons. And so we can go and look at the case studies and say, is our thing right? Now models, so what you're doing is you're kind of tweaking them to match the finite set of data you have. You never know if the problem has a complexity that you've somehow just curve fitted, basically, to the data points you have, and you haven't captured some dynamic. So we don't know they're right, but boy, you're 100 times smarter doing it that way than just sort of going out there and, what a model shows you, this is way too obscure, but the key is to get adults who don't show symptoms. When mosquitoes bite them, they are the thing that propagates the parasite. There's a stage that's in these adults. And so that turns out to be the key bottleneck to go after. The model has taught us that. And so now we're designing drugs that do that very well, and diagnostics that you can find those adults. So it's night and day different of how we're driving the research budget for malaria because of the model.
Okay. You mentioned at the very beginning, I'm going to segue back into energy here now, because I know you've made personal investments in TerraPower, you mentioned, of course, but you've also, at least from what I could tell from a search of some of your investments, there's a company called Sapphire Energy that it's some sort of algae-based. I don't know what it is.
It's algae. It's algae farming.
There's Ottertail Power. Is that something with Warren, the windmill?
No, that's a utility.
Oh, okay. Eco Motors. That's an internal.
That's a Vinod Colsa thing. That's a very efficient, very unusual internal combustion engine.
What else?
Oh well, I love the energy field, and there is a big market. If you can make a real breakthrough. A few somebodies will get very rich making those breakthroughs. There are market failures that some things like, should you invest in nuclear because the waste thing has become uncertain now? Should you invest in carbon sequestration because will the government, for something that's only about 1 trillion times in volume bigger than nuclear waste, will they agree to take the liability and certify that stuff stays underground and doesn't do anything wrong? So there are things that hold back so that innovation isn't done as much as it should. So I think putting money down, encouraging those scientists, it's a great thing. We need to pursue a lot of paths. If we knew for sure that solar PV would become 50 times cheaper and that this nuclear thing would work, then we'd be done. But boy, are there a lot of problems that have to be solved. And the importance of cheap energy for the poor, even ignore climate change, but that also makes it imperative. The value of cheap energy for the poor is literally life itself. If you can reduce the price of energy, I can show you how you save lives. If you save lives, you reduce population growth, you create this virtuous cycle that 2/3 of the world has experienced, but about 1/3 of the world is trapped out of at this point. So it's fun to invest in the different things. Some I'm very lightly involved, some like TerraPower, I'm deeply involved.
Yeah.